just run through the materials, what's new this year. If you'd like to jump in and maybe do an application after. And I'll do a little unit on machining, because of course you can machine parts from scratch, or you can also alter prefab parts. So there's lots to talk about today. So, hey there. This can be somewhat interactive too, if you'd like. Have plenty of bearings here. So get an idea of the ball bearings and whatnot. So thrust bearings, a bit dense here on the definition. Get an idea. Then just your standard ball bearings here. Open bearings, flange, open, double shielded, double sealed, and flange double sealed.
All of these are legal this year to buy anything you want?
All of these, I'm pretty sure, yeah. What was that? And we ordered ours, I'm sure you've heard of the website, but the MasterCar is a helpful place to order pretty cheap bearings. Hey fellas. Drawer slides. You can imagine for the competition this year, with slides in general, linear slides, drawer slides happen to be the cheapest. So go to a MasterCar, a slide like this, for say the office drawers, where they get the name of course. But this could be helpful for say, a forklift for picking up your box or what. Okay, so you throw a couple pulleys with the slide together, you'll have a forklift in no time. The slides are allowed this year, you'll see them. Follow me on the list here, we're at A now. I'm not covering all these items, you know, didn't want to touch on, for example, all the fasteners that are allowed. That would take about half our presentation. Pulleys, lots of pulleys. We have tons of examples, so we'll give you some time to come up here and check out different pulleys and bearings in a bit. You know, uses, of course, so fire them up with one of those slides. You'll have a forklift in no time when it's motorized. Timing belts. Some of those up here as well. Aluminum tubing.
MasterCar a pretty good resource for all that stuff, belts and pulleys and bearings.
Belts and pulleys and bearings. You have a place you recommend for aluminum and alloys.
MasterCar is often not the cheapest place to get something.
Right.
If you just want one thing and you want it quick, then it's great. And they have a great catalog, so you can find all kinds of things and think about them and then decide whether you want to pay the price or not.
Right.
For some specific things, I have some recommendations for cheaper places to get stuff. You can often find wherever MasterCar is buying it, they're just repackaging it and selling it in small quantities. So if you need more than a few, then if you can figure out where they got it, then you can often get it for half or a quarter or even 10% of what they're charging.
Yeah, so MasterCraft's maybe a good starting point.
Yeah, there's another company called Car Lane that does the same kind of thing, but more for tool and die makers rather than just sort of industrial parts like MasterCard is intended to be a go-to source for purchasing agents for businesses that might need a gallon of working or one day and a piece of aluminum the next day.
Yeah, local resources for all this would be awesome. We're a brand new first year team.
Yeah,
It's
so-
a little overwhelming of
Yeah,
where to
we
find stuff.
get to that in a minute.
Cool. Thank you.
Okay, do you want to touch on online metals now? Because I think that's a
Yeah, that's a
get your
generic
aluminum.
question. Online Metals happens to be a national company that sells cut off pieces of metal and plastics. Now they're getting more and more into plastics. But the nice thing about them is they have a warehouse in Seattle. It's on the ship canal on the south side, just near the Ballard Bridge.
Here, Fremont.
Oh, yeah, so if you can get there, you can order online with a credit card and often you can pick it up the next day.
So I was a machinist for a long time, so this aluminum round we ordered here was from Online Metals. We weren't a huge shop, so they're great because they don't have minimum quantities. So you can order a small amount of aluminum. That's great.
You should probably learn what the term drop means. So one of these guys, if you order something, they're going to cut it off from a longer piece of metal. And eventually the piece they've got left gets so short that nobody wants to buy it. And that's called the drop. And about once a year they'll have a sale that will advertise if you get on the mailing list having our drop sale on Saturday. And you could find pieces that might be certainly long enough to build robot parts out of that are considered to be drops by them and then sold at discounts. That sale just happened about 2 weeks ago. It won't happen again until
Next year.
well, until they get so much stuff lying around that they have to get rid of it. That might be-
Good tip. I used to use Boeing surplus a lot, and of course that's closed down.
Yeah,
Regrettably.
You can still participate in auctions from Boeing, but things like pieces of metal aren't going to show up there.
Get some old machines. Okay, non-motorized turntables and lazy Susans. You often see these in your kitchen cabinets. Serve space, but here's an example of one right here. These are loud. Lead screws and threaded rod. Various types here on your right here. Sprockets attached to your chains. Springs, extension, and compression. We have examples up here. We'll let you go through if you'd like. Circular gears. Non-circular gears. That is our presentation. On raw materials, would you like to do some application to
Yeah,
use some of these parts for?
I spent a lot of time last year worrying about wheels and axles and sprockets and gears running together because we had a particularly robust robot design. And we could actually accidentally perhaps grab another robot that was trying to reach over us and basically shove it up in the air with our lift. It was so robust. And then it was a 40-pound robot that nobody could push around. But we used to strip hubs off of axles and things like that pretty often, and even bend axles. So we wound up getting
magic smoke.
lots of, yeah, motors make a lot of magic smoke. So we wound up buying axle shaft material, which is the 6mm threaded rod, grounded polished rod. And that's the same size as the motor shaft that comes out, so it's quite a bit bigger than the hubs and things that are used for anything but motors. But we decided to use it for everything. And that's this 1144 SR PGP shaft in a 6mm size. You can get it from this, it's actually Parker Metals, but their website is metricum.com. So you will have to call and place an order. And if you choose to do this, then you can use the hubs that clamp onto the motor shaft, and they'll clamp onto this too.
Right.
If you ever want to use a set screw hub on this, you're going to have to bore it out to 6mm. You can buy a ream, or you can just do it with a drill press. Figuring out how to hang on to it is up to you. But you do want to get a pretty good fit. And if you do want to use set screws, you have to file or grind it flat on the shaft, and then use a dog point set screw, which has a flat tip to basically push into it, and then a short cone point set screw behind it to lock that screw in. For reliability purposes, you just put one set screw in, it might last a match, it might last 2 matches, but it will come to a match. But the ones that clamp on and go around and have a twist, slice them and clamp on pretty well are good unless you need an absolute phase orientation. So just a few comments about ordering this shaft. When they say TGP, that means it was turned, ground, and polished, so it actually has a very accurate diameter. That's pretty important if you're going to use it with the hubs and bearings that are provided. And what I wanted was a 12-foot piece. It comes in 12-foot pieces. I think I had to order 2 of them because there was a $50 minimum order or something like that. But I told him I wanted to cut it into 4-foot sections for shipping. And what he did was he said, cut each bar into 2 pieces, 48 inches, and ship with drops. So he wasn't specifying 3 pieces, he was specifying 2 pieces and then ship with scrap, basically. Because I paid for it, I should get it.
Right.
And if I'd ordered 47 inches, I would have got 2 47s and a 49. If I'd ordered 49, I would have got 2 49s and a 46.
Right.
Anyway, so the nice thing about this stuff is it's straight. It's also hard. Maybe talk a little bit about raw materials from the usability point of view, if you just buy annealed steel, it's going to bend pretty easily. If you buy something that's been hardened, then it's going to be able to flex without taking a permanent set. See, I could bend this and then it goes right back. If I did that with a soft piece of steel, it would stay bent, at least partly. However, a hardened piece of steel is probably not going to be straight anymore. So what they did with this was that they hardened it and then they stress relieved it a little bit. So it's not as hard as it would have been if they hadn't stress relieved it, but it's not going to be bent. And then they ran through a cylinder grinder, so it's really quite straight and the right diameter. And that's pretty important for the shaft. Another place you want to know about is American sleeve bearing. You probably see these bearings in your Tetrix kits. If you want to buy them from Tetrix people, like $15 each. So this one cost me 43 cents. American sleeve bearing is where they get these. So no one will be able to tell you didn't buy it from the Lego people. They're 5/16 outside diameter, which is smaller than the 8mm diameter that is specified for the Tetrix, but it's only smaller by a couple thousandths of an inch. So it will fit. You can Loctite it in and it'll stay. Beautiful fit. Most of them come with a 3/16 inch hole. And these guys sell them with a 3/16 inch hole. You're going to want to have them so that some of them at least, so you can put them on a 6mm shaft. And to do that, you're going to have to read them out yourself. And that's another case for figuring out how to hold it is the tricky part. And the best way to do that is probably to get a plate of metal and put a hole in it that has a fairly snug fit. And then glue the part in, bore it through, and then push it back out again. We should probably talk about the different colors of Loctite.
The taste, it's got a sweet taste.
It has a sweet taste.
You don't want to learn that.
You don't want to learn that, right? Nor do you want to learn what the smoke smells like by getting it in your face. Because it's cyanoacrylate smoke, and it will make your eyes burn and you should die. So don't solder anything that's got Loctite on it. You should wash it off with acetone first. But so you'll need a 6mm drill or a 6mm reamer, or both. If you're 5.5mm drill and a 6mm reamer, if you want to do a good job with a sleeve.
If I could talk for a minute about machining and
Yeah.
how that can come into
Okay.
applied robotics. I recommend for, let's see, machining. So I was a machinist at the UW Ocean Architecture Department for 10 years, and I made parts for robots. This is how I became the build mentor on our team. You can see me here working on a mill and a lathe. Exactly the two machines I have on the part there. Let's get to a certain. I made parts for the Sea Glider robots. Here's an example part that was made. It had a little mistake here, which is why I was able to take it home. But an idea that's just housed a sensor. The Sea Glider robots go out for 6 months at a time. So this is just inspiration. This is why we build robots in high school, right? We'll be building these one day. Wanted to just talk to you about what you can use mills and lathes for, and just to get the two machines into your lexicon. When people talk about machining, they're often talking about these two machines, and then of course bandsaws and whatnot. But you can do just about anything with these two. A mill turns a tool into a stationary part, and a lathe, on the other hand, turns a part into a stationary tool. So you can imagine uses. You can turn a rod into a threaded rod yourself. You can bore down an inside diameter, and this is on a lathe. That's where you'll work on rounded materials. Mills, of course. So right here you see some milling on an end mill like you see right here. That can be great for making adjustments to parts. So uses for robotics, these two machines. Just about anything, making customized parts from raw materials, or as I touched on a bit earlier, customizing prefabricated parts. So you order a Lazy Susan here, and you can say drill out or make necessary changes to this. Exact same thing with Tetrix parts. You're very bound to the clearance holes here with your fasteners. Having a machine handy can add a lot. We actually don't have either of these machines here in this building, so I know it can be a resource issue, a space issue where we put them. But lots of people do have these in their homes. So you said you have what, a mill and a lathe, hard engine in Bridgeport. My dad and I share a Bridgeport, actually, it's in his garage. We're struggling to find a lathe right now. But we have a drill press upstairs we often use like a mill, but of course it doesn't have all the same functions. So I do, recommend the advent of CNC mills and lathes. They've actually, become a lot cheaper to find your traditional types. So you can find them used on Craigslist or just find, kind of a gearhead, blue collar fella who may be in the neighborhood who may have something similar. Have you done some machining on yours for your robot in the last, month, week, day?
I don't make, I used to make parts for the kids from time to time. If they would actually come up with a design drawing, then I would be willing to make them for them. I try real hard to teach kids how to make things rather than make them for them. Kind of design that way.
Yeah.
Alika can tell you how much she's learned about how to make things out of metal in the last 2 years. She's been quite good at it. Actually, drilling a hole where you want it to is a lot harder than, particularly if you're trying to make a shaft line up at both ends or get gears to mesh nicely. The gear meshing thing requires that the holes be accurately located within a 10th millimeter, so that's hard.
It's actually machining a gear right here. I had to place it in a bit of an aluminum rig there. Get this gear machined with those lined up holes like you were mentioning.
Could you turn off the light over there?
So yeah, I'm not taking a bunch of parts home for these fellas and machining them, but I think it does, they're able to put a drawing on SolidWorks or sketch it out on graph paper. I mean, it's a great skill to learn. As you see right here, SolidWorks was used for this gear.
We talked a little bit about aluminum stock and
Yeah.
what it comes as and what you want to do with it.
The alloys in this other presentation you want to talk about?
Yeah, alloys is good. You just go to one of these websites and try to order a piece of aluminum, you're going to be inundated with
Get out of your way.
numbers. And this is a real good summary of the different numbers you might run into. 2024 is a really strong alloy. You almost always want to see it as 2024 T6 or T4, I guess. It's not corrosion resistant, it's not well. That's not important. You really need the strength. It's a more expensive aluminum alloy that you can use. We almost always use 6061 or 6063, and in fact, usually it's the 6063 because the extrusions come with square corners, whereas with 6061, it's got rounded corners. You'll see this if you go to the Online Metals website. If you just want a simple square tube or a simple angle or a channel or something like that, 6063 T6 or T62 or 61, any T6 ... is fine. When I say T, that's a temper. So it's actually been heat treated to make it harder because aluminum is pretty soft when you just get it bend it, it'll stay bent. Which is real nice if you're trying to make a curvy part, but if you want to make a part that's straight and it's going to stay straight, you want it to temper so it will bend. The same as you did with the steel, you wanted a hardened piece of steel, this is a hardened piece of aluminum. And this 6061 is what you see aluminum bolts made out of. Block is done and welded together. So if you think you need to make something that's going to require welding, then you probably want to pick 6061 or 6063. 6061 is what you welded. The other ones are, as far as aluminum goes, there's 7075 aircraft aluminum, which you can get from Aircraft Solutions Specialty. That's sort of a high-priced, really high-performance aluminum alloy. That's what aero shafts and tent poles are made out of. Very high yield points, so it can depend a lot without taking the permanent set. Any questions about that? It's cheap and easy to buy English numbers, aluminum angles and tubes. You can get half-inch angle with 16-inch walls. You can get half-inch angle with 8-inch walls. You get 3/4, 1-inch, 1.5. You want to get sizes in between. It's hard to find. And if you want metric sizes, they always cost 2 or 3 times as much. So really try hard not to use metric anything unless you have to. The Tetrix stuff, all the holes are on metric pitches. You can certainly put holes anywhere you want on a piece of angle or channel that you buy. But if you want to actually have metric outside dimensions, you're going to have to pay a lot for it. So try not to do it. Aluminum's a lot cheaper than steel, but very strong.
Are these sites over here good sources for this?
Online Metals is a great source for aluminum parts. It's local, it's reasonably cheap, and they don't have a minimum order. There are places that might be a little cheaper for specific aluminum parts. Orange aluminum would be one of them. Aircraft Spruce and Specialty is probably cheaper than Online Metals, and they don't have a minimum either, but you have to wait and they ship it. It's online, you just go and get it. Metricmetals.com, I wouldn't buy anything there except this 6 mm shaft.
Now, Online Metals will UPS or FedEx.
Yeah, they will, and they also sell plastics, as I mentioned. So if you want, for example, to make a plastic part to slide a forklift with, or you want a plastic bushing that you're going to put a hole through, you can get nylon, which is a reasonably inexpensive and reasonably machinable material. If you want something that has a higher yield point, so you're going to put a high load on a plastic part, you don't want it to breathe, you don't want it to melt, which is quite a bit more expensive. It stinks when the machine won't do it. But it definitely outperforms nylon for a better. Yes?
What, if anything, would you recommend wood for?
Wood is great for something that needs to be light or something that needs to be cheap, or both. Soft woods in particular are quite light, and they're pretty stiff, at least in the grain direction. The other direction, they tend to crush pretty easily. They don't handle concentrated loads very well, so they're not as good as aluminum, for example, if you're going to put a screw in and torque it down hard. You can just strip the threads out of the wood, or you can crush the wood. Whereas with aluminum, that really happens. Hardwoods are really good for mold making because they're a lot cheaper than a metal part would be, a lot easier to machine than a metal part would be, and yet they're quite solid. Pretty strong.
Oftentimes, using machining mills and lathes, it's synonymous with, metalworking, whereas carpentry lathes, we have one here. Those are often a bit, not as heavy duty, so they're more compact, easier to fit in a small space.
You don't typically hold as tight tolerances with as you do with metal. It would be pretty hard to make a big part.
1,000th of an inch.
Wood will expand and contract as really cheap. You have to talk about that.
What was the material for bushing, you were saying, high strength?
Oh, the metal ones or the plastic?
The plastic ones.
The plastic ones, yeah, nylon
Or glide and
is
stuff.
a pretty good one, and Delrin is a really good one. The generic term for Delrin is acetal, ACETAL, and the trade name from the nature then is Delrin.
REN, DEL, REN.
Yeah, ELRN.
So question, how do you, so the shop I was at, we always just went to McMaster, but maybe that's because we were in the public sector. How do you track parts? Like, how do you track this pushing down?
How do I find it?
From say, yeah, $15 to 40 cents, or you said McMaster is often a good starting point, how would you
So
go
there's
down?
no way to figure out from looking at McMaster's website where they got it.
Yeah.
They specifically avoid letting you find that out.
They want to get in the.
Occasionally, if you buy the right number of parts, they'll get lazy and ship you the whole package that they got from the vendor, with the label on it. But other than that, you
Google
just-
is a great,
you can just try to figure out what all the different names are that people use for that. And go, okay, it's made of bronze, so I'm gonna look for bronze bushing. Okay, it's sintered, I'm gonna look for sintered bushing. I'm just gonna look for bushing. It's got a flange on it, I'll look for flange bushing. These are actually sintered bronze flanged bushings. If you put that in Google, you come up with ASB, American Sleeve Bearing. You get very quickly to the right site. They sell them in a variety of inside and outside diameters and a variety of lengths. Just figure out the one that matches the Tetrix one.
Raven, you on it? Find us cheaper parts? So would it be more helpful to keep us up here and you back there? Would you like to come up and ask us questions one-on-one? We can get some different pulleys and bearing styles out and kind of get a little more hands-on.
Any good source for bearings and gears? Or not bearings, just gears? It seems like in Texas you get, 20, 40, or 80, but that's all you get.
Yeah.
And they don't really line up when you mount the
So
motors.
the gears in the Tetrix universe are module 0.8 gears.
Mhm.
And so if you can find a source online where you can buy aluminum module 0.8 gears,
Okay.
they'll all fit. They won't fit the 32mm hole pattern unless you use the standard numbers, or the 120. But you could use 20 and 60 together with the 40, 80, and 120 and fit a 16mm hole pattern. And a lot of the Tetrix pieces have that flat piece you had. They have additional holes that are 16mm apart, so you can do it. I would try to stick with something like a 16mm pattern instead of a 32mm pattern, and use the in-between sizes if you can find them. We've actually contemplated making our own gears. We've got a CNC machinist guy who's got to work for us. And I found that you can buy a full set of hobs for module 0.8 gears from eBay for like $120. So we're still contemplating whether to do that or not. The kids kind of have to want it before everything's going to happen.
well, you can use gears of any
Like
shape
you're
and
allowed
size
to use
this year.
any gears you want, but if you're not building a Tetrix robot, then you can go to any one of the standard gear manufacturers. The trouble is they're going to be expensive. McMaster sells gears. Boston Gear is a big gear manufacturing company. I have not actually tried to buy any gears from them since I was 5 years old. That's a long time. But you can look on eBay and often you can find stuff there that satisfy you. So does everybody have a feel for how to pick which material you want to use for a given part? You just try it out a bit and see if it breaks, and pull out all aluminum and bend and pull it out of steel.
That's a good order of operations.
In the lift that we made last year, we did kind of a crude design exercise and we built it, and then a lot of things bent and a lot of other things broke. We built the whole thing stronger in certain places and lighter in a lot of places. We found that it wasn't going up fast enough. And when we calculated how much power the motor had versus how much power it took to move it up, we realized that we weren't gearing it right, and that it was heavier than we needed it to be. So we lightened it, particularly the top parts to move the most, we lightened those. We changed the gear ratio. things faster with them actually do it. Made a big difference to the competitiveness of the robots. You left a lot on the table when you first designed it, you didn't do the math.
With the tubing and the alloys, it seems like the Tetra stuff is fairly limiting as far as the spacing and everything else.
Yep.
So we're wanting to use more, again, as a first-time team, leaning more towards just extruded stuff. What's the thickest you anticipate wall thickness on
We
this?
buy 8-inch wall material for practically everything.
Right?
Something needs to be really light, it doesn't need to be very stiff. It's probably just 20-inch wall. I don't think we've ever even had to go a part of it. And you can set some kid with a drill press to drilling out metal that it doesn't need to be there, so if I want 8-inch parts that are really light, it's just too much.
What about, as far as joining stuff, you've been talking about weldability, and that's,
Yeah,
aluminum welding is probably outside the realm of most teams.
yeah, I think you're right, practically all teams.
So,
We do one running all the time.
so heavy duty rivets and bolt nylocks and
Yeah, that's an interesting point. We have, in the Tetrix universe, you've got these 632 screws and what they call cap nuts, which have a built-in lock washer. It's not a real lock washer, it just plays on TV. They will fall off on the field.
pitch them to get nylocks and.
Yeah, nylocks, and then, if the nylock goes on too easily, it's probably been used too many times, and you should just throw it away. You want to buy hundreds of nylock, 632 nuts. And there are a lot of places where 632 screw just isn't big enough. We use a lot of 1032s because you can get enough threads in an 8-inch piece of aluminum that a 1032 screw will actually weigh 100 pounds.
Just tap into the.
Just tap the aluminum straight in and then Loctite it up and assemble it. That's another reason for using the 8-inch material. If it's thinner than that, you gotta rivet it. And the rivets are great if it's an assembly that you're completely sure about and you're not gonna have to disassemble it in a competition or something like that. But they do fail after a while. They'll start to, if you're in a competition a lot and getting banged looking around, they'll start to deform holes for the barge and so on. Whereas the bolted joint that is really 8-inch apart is probably
You're saying a tap hole and 8-inch aluminum hole.
yeah, a tap 1032 hole and 8-inch aluminum hole, particularly if the other part, you've got a screw with an unfitted shank on it.
Right.
And the second part is a good fit to that shank. And the hole really well.
It's just an example of what we refer to as like Swiss cheesing. It's getting material out, so this, big hole here, it was actually, punched to drill through and then milled it. That's just for lightning. Real easy to do with aluminum, especially if it's an 8 or 16 inch.
Yeah, and if you're doing that in sheet metal, it's often safer to do it with a greening punch or something like that. You can find in the sheet metal shop, rather than trying to do it with a drill. Drilling sheet metal is dangerous.
It's very dangerous. Doing something like this could be pretty dangerous. Too. You have some pretty sharp corners here, so set that up.
Drill press safety is a big deal. Drill press and bends are probably the most dangerous two things you got in the shop. The key on the drill press is to clamp it down before you try to drill it. It's a really big part in a really small hole. You might be able to do it by hand, but anything else you want to clamp it in place before you try to drill it. On the bandsaw, the big thing is make sure it's really sharp. Push it with something other than your hand. I'm waving my finger around here. You probably can't see it from very far back. There's a scar that goes from there to there, and it goes all the way into the bone.
Bandsaw.
No bandsaw blade.
If it was sharp, you wouldn't have a finger.
No, if it was sharp, I wouldn't have been pushing so hard. It wouldn't have slipped. The
We're swapping out our wood blade and our metal blade a few times a week these days.
And there is no such thing as a fiberglass blade for a bandsaw. Anybody cuts fiberglass on your bandsaw, throw away the blade.
Any good sources for polycarbonate?
Tap plastics is not bad. Polycarbonate is pretty expensive. Really expensive.
Any better ideas for protection or mounting boards or?
No, polycarbonate is quite good. And the other obvious alternative is plexiglass. Polymethyl tactile plastic that's commonly used for airplane windows and things like that. The problem with plexiglass is it will shatter if you give it an impact. And it'll crack easily when you're drilling it. If you want to make parts out of plastics like that, you should get drill bits that are ground for cutting plastics. Otherwise, they can move around and break the plexiglass or gum up and stick in polycarbonate.
Okay.
Just pick 2 or 3 sizes that work for you.
I think you worry about, especially when you're cutting, if you cut too fast, it'll heat up and then it'll melt and then reform behind the blade.
Yeah. You might have this part of the blade stuff.
Right.
So cutting polycarb, is that table saw, bandsaw?
Bandsaw is safer than a table saw for plastics.
Chop saw.
Chop saws work well. Yeah. Table saws will cut plastics just fine. You just want to feed it slowly.
Okay.
Make sure you don't start to smell smoke. If it gets hot enough that you can smell it, then you don't do that.
What about thicknesses? Any guidance on thicknesses?
We use what, 8-inch polycarbonate for
I think we
shrouds?
we use mostly 8-inch, but we use a little bit of quarter-inch, I want to say.
Yeah, there was something that was sort of structural that we used 4-inch polycarbonate.
Or, I'm not even sure it was structural, I could have just had it across the distance from one of
Yeah, and if you're gonna bend it with a hot air gun, then you want to use thinner stuff, like 16 inches, 30 seconds.
We've had good luck with molding covers with bending plexiglass.
Okay.
Was that plexiglass or
That
polycarbonate?
was polycarbonate.
Okay.
Well, you can bend either one, but polycarbonate
Less shadow.
is shatter resistant, and I think it bends at a lower temperature.
So for covers and stuff like 1/32 inch, thick stuff?
Not a 30 second, 16th kind of a minimum.
Okay, so 16 for covers and eights.
And a 16th of an inch, even a polycarbonate uses 2 kinds of
That's good.
So that's something to watch for, is making sure you don't start bubbling part of the
Right, if your heat gun bubbles the part, then it's not going to be the original material that's got good shatter resistance anymore.
Right.
It's a lot weaker if you boil it. Wow.
So the hand was full of bubbles.
Yes.
But it didn't need to take.
So what kind of machine work mentioned have you done recently? Were you working on Tetris parts or were you making parts from scratch? Or?
Recently, this season, we haven't started any machining yet.
Okay.
We just did the things that there's
Yeah.
prototyping stuff. We're about to move into the phase where we'll be CADing things and keeping all this in mind for our design. So,
Making sure they're actually machinable. We ran into that problem last year, where we made designs that you couldn't machine. And that was a disaster.
where was that?
With like a giant metal thing with a hole that was too close to the edge, and so you couldn't actually play with it, and it was like,
Oh.
yeah,
Yeah, Brian is not happy.
yeah.
When he's not happy, you're not.
Nothing a good rig can't fix, huh?
Well, one of our mentors has got a big CNC machining center. But if you want to build something that's a millimeter bigger than his machining center can take, no dice.
Yeah.
Want to hold something in a way that he hasn't got holding fixtures for, no dice.
Can be a little trickier because CNC machines, those who haven't seen them, they're often fully enclosed, there's a lot more cooling used in them, so.
Yeah, it's just a lot more power on this spindle.
Was that cool? It smells terrible. Yeah, so you had some CNC experience?
Oh, I've been CNC, and then if the coolant breaks, it's where you're like,
Oh, yeah.
that sucks. And then you smell like coolant. Like,
Yeah, parts come out wet.
Coolant all over the place. It's not fun.
Any other questions?
Oh, I'm sure I do.
Yeah.
It's a whole new world, this is step up from FLL.
Thought process is completely different from FLL.
And the parts are totally different. We got a very,
Yeah, I think the
They do all
goal
that
is to
well.
move the kids toward understanding how it's done in the real world.
Yeah.
and
Yeah.
developing
FLL is more
capabilities step by step.
mission-based.
Economic feasibility is a big
And
factor.
you have parts that specifically go together, and you can't break things usually.
Yeah.
this is
The
a
motor.
bigger universe of possibilities.
Learning
There's a
how
lot
to
more.
make parts, even ones that seem like they're really simple, and really bite. Remember you designed that simple little thing that was made out of a piece of channel? And it was really simple, just drill these 4 holes in it and then bolt it in. And the person that tried to make it measured the locations of 2 of the holes from one edge of the part and the other 2 holes from the other edge instead of measuring them all from the same place. And the part, if it had been at the nominal dimensions, would have worked fine. But when it's the same person or a different person, but when the person then saw the part out of the stock, it came out a little bit short.
Right.
And so the 2 holes were not.
About a blade thickness short?
No, it was all within tolerances, but the act of measuring from 2 different reference points instead of from one reference point, assuming that the part was nominal, screwed it up completely. And for a long night, having to connect those parts.
The difference between
Happened on short notice.
FLL and FTC is, in FTC you have to think about, like you have the teleop portion of it where they're actually controlling it. And you have to take into consideration all the other variables that happen at the same time. So it's more about the game, the strategy around the game, whereas with FLL, it's more about the process, going through, okay, you have all these different attachments that you need to put on this robot that have different ways to connect it, and how one attachment can be used for other things. The process of just going through the different missions on the game, it's mission-based, where FTC and FRC, it's more from the game-based.
Somebody in the first session I went to this morning pointed out, one of the things about FTC is the other robots are going to see. And you can't just build something that you can't take a hit. Reliability is as important in determining this functionality.
Yeah.
If your robot looks great in the first match and it doesn't show up for the next match, it's not going to do well in the tournament.
In FLL, you're also, it's you against yourself, it's not that,
Right.
there's not that much interaction.
We've been having a lot of conversation about that, it's not just you against your opponent even. This is you with an unknown teammate
And
against 2 unknown opponents.
taking in those variables and
Yeah.
factoring that into your robot design.
So I have previous experience in the MAID League, so Marine Advanced Technology Education, so we competed in the Weyerhaeuser pool down south. You make the nationals, you go to Monterey Bay, but my big learning curve has been getting used to wheels. So I'm so used to propellers and
Yeah.
underwater materials. So,
Yeah, and we're thinking now about what having timing belts means, because
yeah.
one of the things that was a problem before was this tracked vehicles were kind of limited by the available tracks and so on. You can use timing belts, use that for a track.
Turn it around.
You can also use it for the same things we do with chains now, and chains have issues, a lot of issues. And timing belts have issues too, but they're different issues. So timing belts might turn out to be something.
What kind of issues have you found with chains?
It's very hard to get the tension exactly right every time. It's not, you can't do it well enough by feel necessarily. And you have to, in your structural design, you have to account for the tension that it's going to take the chain on. Particularly if you're running a chain over a long distance, it's very easy for it to start flapping and bounce off the sprocket or something like that. So you have to wind up putting idlers in to keep it going where you want it.
And if you make it too adjustable, it will easily get out of adjustment, unless you make it really
Yeah.
tight.
And they can bind up and burn up motors, Everything seems to wind up with burning up motors. It's a really bad thing. Well, the other thing about the
Gravity
motors
blocks.
that you want to know is those motor shafts are not designed to handle side loads or axial loads. The bearings inside that gearbox are really
cheap.
So basically, do not hang a wheel off of a motor. Do not put a lot of chain tension on a sprocket that's on a motor. It's okay to have a chain on a motor, particularly if you can support the other end of the shaft, but there isn't enough room to do that. So if you're gonna put a sprocket on a motor and put a chain on it with a lot of tension, you're gonna put a side load on the motor shaft and the back bearing will fail. And then the gears inside will lose teeth and it'll wind up. You can separate the motor from the gearbox. So if you ruin a gearbox and you ruin another motor, you can take pieces and put them together. But you have to lock that tricks together. And probably the scariest thing that you could ever do is soldering leads on the motor, soldering wire leads under the tabs on the motor. The insulation that those tabs are in melts at a fairly low temperature. And the wires on the inside are soldered on poorly. And they get hot and the tab starts to move because the insulation's hot. You can ruin a motor. I wouldn't send any first gear kit with a soldering iron off to put wires on a motor. It's better just to let it boil.
Another technology that's just coming online is 3D printing. I mean, it's not as robust as metals, but
And that's another poster,
Yeah.
contemplated making, but yeah, it's.
Yeah, you can usually find somebody that's got a 3D printer.
Our team owns one, our,
Just ordered a MakerBot 2, we had to make about one. It's a portable 3D printer. It's not one like that.
Yeah, so the part of the PLA parts are not very strong, the ABS parts are pretty strong. ABS is a really good class. It's not solid resistant and it's not heat resistant. So for robot applications, it doesn't break, it doesn't shatter like that. So you can 3D print ABS parts. We have some curved parts on our robot.
We have some on our current varsity teams one, it's the blue parts you'll see when we get to the build section, but all that bright blue is 3D printed.
I mean, you could probably do a lot of check prints in PLA, but when you want to go to competition, you can probably want the ABS.
Yeah, PLA is not going to stand up to being whacked up by closing.
Might work for somebody that's interested.
Yeah, like a frame to hold up a battery.
Well, we're at time. Thanks for coming, everyone. Rock tight colors, were you gonna?
Oh, yeah.